Hello and welcome. We are the ecowave team, and today we'll walk you through the full user-centered design process behind ecowave, a mobile app that centralizes the organization of citizen beach cleaning brigades in Yucatan. The headline of today is our usability validation with real users. Here's what we'll cover in the next 10 minutes. We'll recap the problem, walk through our 7-stage UCD pipeline, and spend most of the time on the parts that are new in this final delivery. The critical use case, CU002, the 3 prototype iterations, the heuristic evaluation, the KLM analysis, and the headline, the usability test with 6 users. We'll close with lessons learned. Yucatan's beaches receive over 33 tons of trash per year that volunteer brigades clean up. But the coordination is broken. Brigades are scattered across Facebook and WhatsApp. Volunteers have no visible incentives to stay engaged, and reports to authorities are still made by hand. ecowave is a mobile platform built on 3 pillars: an interactive map of brigades within a 25-kilometer radius, a verified check-in via QR code with GPS as fallback, and gamification with 4 progressive badges from bronze to platinum. Our process followed the ICO 9241/210, the international standard for human-centered design. 7 iterative stages, each closing with a peer-reviewed artifact before moving on. Traceability between stages was kept through a user requirement to functional requirement to non-functional requirement matrix. What's new in this final delivery is the right side of the pipeline, the heuristic evaluation, KLM analysis, and usability testing. The left side, research requirements and specification, was delivered in previous milestones. The numbers in the boxes show the volume of work behind each stage. Out of 8 user requirements, only 1 was marked as critical. This requirement stated, confirm attendance through check-in. From it derived use case CU002, perform check-in, which alone concentrates the 4 quantitative non-functional requirements you see here. No more than 3 taps, no more than 30 seconds total, visual feedback under 500 milliseconds, and full WCAG AA accessibility. Because of this concentration of requirements, CU002 is a single flow we submitted to all 3 evaluations: heuristic, KLM, and user testing. 3 prototypes, each answering a different question. The low-fidelity sketches in black and white validated the architecture. No color, no brand, just structure. 3 structural decisions came out of this stage. The map is the home screen. The check-in has 2 routes, and the success screen is independent. The medium-fidelity prototype with clean components and neutral grays validated hierarchy. 3 changes mattered: cards instead of flat lists for check-in options, a visual progress bar, and a touch target of at least 44 by 44 pixels for the main button. The high-fidelity version applied our brand palette: Ocean Deep, Teal, Sun, and Micro Interactions. This is the version we tested. 3 of us applied Nielsen's 10 heuristics independently to the high-fidelity prototype. We then consolidated 9 findings in a joint session and signed severity by consensus. 3 findings were major: severity 3, 4 were minor, severity 2, 2 were cosmetic, severity 1. The 3 major findings were resolved before user testing. We added a "you are inside the event area" indicator to prevent errors, a recovery block for when QR scanning fails, and a continuous scanning animation so the user knows the camera is working. Resolving the majors before user testing meant the session was free to surface finer issues, which it did. Before involving real users, we predicted the task time using the keystroke level model from Card, Moran, and Newell. We then came up with atomic operators, 5 mental acts, 3 taps, 1 repositioning, and the system response time. The test was controlled and replicable. The objective was to validate that the critical use case meets its 4 non-functional requirements in a realistic environment. 6 participants, 4 casual volunteers between 19 and 34 years old, plus 2 organizers aged 32 and 41, recruited externally to the team. The scenario simulated arriving at a Chicxulub cleanup, opening the app, scanning the QR, and verifying the badge. The instruments were a pre-test profile questionnaire, as well as a post-test and observer notes on time, errors, taps, and feedback latency. To reproduce real conditions, we used a high-intensity LED lamp at over 10,000 lots to simulate direct sunlight on the device screen. Here's what we measured: mean check-in time, task success rate, mean SUS score, mean feedback latency, and the bottom line. Here we can see the per participant breakdown. The bar chart on the left shows check-in time per participant against the KLM prediction in black dotted line and the non-functional requirement 5 threshold in red. The table on the right is the full per participant breakdown, time, taps, SUS, and whether they needed any help. Here we can see 2 patterns surfaced from interviews and observation that the heuristic evaluation had missed. First, LED reflections. 4 of 6 participants tilted or shaded the screen during the QR scan. Second, a transient confusion when entering the dark QR scanner from the light check-in screen. And a positive bonus, 5 of 6 participants spontaneously asked how to unlock the next badge. The gamification is working. Now, lessons learned. What worked? The KLM prediction was within the literature range, and resolving the 3 major heuristic findings before testing freed the session to surface real qualitative insights. What's next for iteration 2? Boost contrast of secondary information on light background screens, soften the transition between light and dark screens, close the 4 remaining heuristic findings, and move from prototype to MVP development. The roadmap is concrete and grounded in evidence. Let's keep in mind that the whole team worked together in this project and everyone did their part. Thank you very much for your attention and time. Questions are welcomed.